Today we're on pages 41 and 42 of our textbook. We're going to talk about one-to-one functions. Exercise number 1 asks us to consider two functions given by the equation f of x equals 2x and g of x is equal to x squared. Map the domain -2, 0, and 2 using each function. Fill in the range and show the mapping arrows. So for f of x is equal to 2x. So an input of -2, we replace x with -2, and we get 2 times -2, which is -4. So -2 maps to -4. 0 in for x, 2 times 0 is 0, so 0 maps to 0. And replacing x with +2, 2 times 2 is 4, so 2 maps to 4. And g of x is equal to x squared, taking -2 and replacing it in for x. -2 squared is 4, so -2 maps to 4. Putting 0 in for x, 0 squared is 0, 0 maps to 0, and evaluating g of x for 2, 2 squared is 4, which we already have. So +2 maps to 4. What is different between these two functions in terms of how the elements of the domain get mapped to the elements of the range? Well, in function f, each element of the domain maps to a unique range element. Whereas in function g, an element of the range, in particular 4, has 2 inputs. It has 2 different inputs. So in order to be one-to-one, each input has only one output and vice versa. Each output has only one input. A function f of x is called one-to-one if x of 1 does not equal x of 2 implies that f of x of 1 does not equal f of x of 2. In other words, different inputs always give different outputs. Exercise number 2 of the 4 tables below, 1 represents a relationship where 1 is a one-to-one function of x. Determine which it is and explain why the others are not. So looking at table A, we see here that an input of 4 has 2 different outputs. So this is not a function. So is it a function? No. Input 4 has 2 outputs, so it's not a function. And then it can't be one-to-one. In order to answer whether or not it's one-to-one, it first needs to be a function. So this is not applicable. If it's not a function, then it cannot be one-to-one. Table 2, -2 maps to 1, -1 to 0, 0 to 1, 1 to 2. This is a function. Each input has a unique output. So function, yes. Is it one-to-one? One-to-one? No. Because the output 1 has 2 different inputs, has an input of -2 and an input of 0. Table 3. First, is it a function? Does each input map to a unique output? 1 to 2, 2 to 4, 3 to 8, 4 to 16, yes. And does each output have a unique input? Yes. So choice 3 is the one that is a one-to-one function. And let's just look at table 4. -3 goes to 10, -2 to 9, -1 to 7, -2 to 10. This is not a function. The input -2 has 2 different outputs. And then one-to-one is not applicable. Next, the horizontal line test. If any horizontal line passes through the graph of the function at most one time, then that function is one-to-one. Similar to a vertical line test to determine whether or not something is a function. So now, once we have a function, we can use the vertical line test to determine whether or not it's one-to-one. This test works because horizontal lines represent constant y values. If a horizontal line intersects a graph more than once, an output has been repeated and the function is not one-to-one. So consider the following 4 graphs which show a relationship between all the variables, which show the relationship between the variables y and x. A, circle the 2 graphs above that are functions. So in this case, to determine if it's a function, we're using the vertical line test. So 1 is a function. This fails. 2 is not. 3 is not. 4 is. So 1 and 4 are functions. Explain how we know. Pass the VLT, the vertical line test. Of the 2 graphs you circled, which is one-to-one? Is 1 one-to-one? No, when we draw a horizontal line, it intersects our function at more than one place on the graph. So 4 is one-to-one. It passes the horizontal line test. And vertical line test. So So again, in order to be a one-to-one function, it first needs to pass the vertical line test and then the horizontal line test. Exercise 4, which of the following represents the graph of a one-to-one function? This one is not a function. This is a function. So is 3. And so is 4. So 2, 3, and 4 are all functions. Two is not one-to-one. Looks like 3 is a one-to-one function. 4 is not. Our answer is 3. Exercise 5. The distance that a number x lies from the number 5 on a one-dimensional number line is given by the function d of x is equal to the absolute value of x minus 5. Show by example that d of x is not a one-to-one function. So showing by example, that means we need to choose values for x. Let's see. Let me evaluate d of 4, right? So let's say d of 4 is going to equal the absolute value of 4 minus 5. And 4 subtract 5 is negative 1, and the absolute value of negative 1 is 1. What other value, if we put in for x, would result in 1? If we use 6. So if we evaluate d of 6, minus 5 is 1, and the absolute value of 1 is 1. So this is not one-to-one. Inputs of 4 and 6 give the same output.